When creating panel schedules and dealing with three-phase breakers, several options exist for indicating the breaker's configuration and the phases it serves. Option involves circuiting the breaker by all three phases using a notation such as panel POM-1/3/5, where POM-1/3/5 equals phase A, phase B, and phase C. This method clearly indicates that it is a three-pole breaker, making it easy to identify. Option B circuits the breaker on a single phase, for example, panel POM-1, where POM-1 equals phase A. In this case, you would add a note to the panel schedule indicating that the breaker is a three-pole breaker. Option C uses a notation like panel POM-1/3P, indicating the panel and circuit number, followed by 3P to denote that it is a three-pole breaker. Option D circuits the breaker by all three phases but uses a single circuit number, such as panel POM-1/2/3, where POM-1/2/3 equals phase A, phase B, and phase C. The preferred option is generally option A, panel POM-1/3/5, as it is the most clear and concise method, and it is easily identifiable as a three-pole breaker. When creating panel schedules, there are several options for indicating three-pole breakers. Firstly, using a notation such as panel POM-1/3/5, where POM-1/3/5 equals phase A, phase B, phase C, effectively circuits the breaker across all three phases. This method offers clarity and ease of identification for three-pole breakers. Secondly, another approach involves circuiting the breaker on a single phase, like panel POM-1, where POM-1 equals phase A. With this option, a note should be added to the panel schedule, specifying that the breaker is a three-pole breaker. Thirdly, a notation such as panel POM-1 open parenthesis 3P close parenthesis is employed. The panel and circuit number are indicated, with the addition of open parenthesis 3P close parenthesis to signify that it is a three-pole breaker. Fourthly, using a single circuit number to circuit the breaker across all three phases is an option. For instance, panel POM-1/2/3, where POM-1/2/3 equals phase A, phase B, phase C. The most favored approach is generally option A, panel POM-1/3/5, because of its clarity, conciseness, and ease of identification as a three-pole breaker. Additional considerations include ensuring the panel schedule clearly shows which circuits are connected to each breaker. If a three-pole breaker is used to protect multiple circuits, these circuits should be clearly labeled on the breaker itself. Consistency in the panel schedule is also important throughout the project. When detailing three-phase breakers on panel schedules, various methods exist to clearly indicate their configuration and the phases they serve. Option A, using a designation like panel POM-1/3/5, clearly circuits the breaker across all three phases, where POM-1/3/5 corresponds to phase A, phase B, and phase C. This approach offers excellent clarity and easy identification of the three-pole breaker. Option B involves circuiting the breaker on a single phase, for instance, panel POM-1, where POM-1 represents phase A. When using this option, it is essential to include a note on the panel schedule specifying that the breaker is a three-pole breaker. Option C uses a notation like panel POM-1 open parenthesis 3P close parenthesis to denote a three-pole breaker. The panel and circuit number are indicated followed by open parenthesis 3P close parenthesis. Option D provides a single circuit number to circuit the breaker across all three phases, such as panel POM-1/2/3, where POM-1/2/3 represents phase A, phase B, and phase C. For most applications, option A, panel POM-1/3/5 is the preferred method. It offers the most clear and concise approach and facilitates easy identification as a three-pole breaker. When creating panel schedules, it is also important to consider other factors. The panel schedule must clearly show which circuits are connected to each breaker. If a three-pole breaker protects multiple circuits, clearly label these circuits on the breaker itself. Consistency in the panel schedule must be maintained throughout the entire project. When planning a panel schedule with three-phase breakers, several notational choices are available. The first is option A, where you show the breaker connected across all three phases. For example, panel pon-1/3/5 will show that pon-1/3/5 equals phase A, phase B, and phase C. The advantage of this approach is the clear identification of a three-pole breaker. The second option, option B, is to show the breaker connected to just one phase. For example, panel pon-1 with pon-1 equals phase A. When using this notation, include a note in the panel schedule that the breaker is a three-pole breaker. A third approach, option C, would be to use a notation similar to panel pon-1 open parenthesis 3p close parenthesis. Here you are indicating the panel and circuit number and using the open parenthesis 3p close parenthesis as a flag that it is a three-pole breaker. The final option, option D, would be to show the breaker connected to all three phases but using a single circuit number. For example, panel pon-1/2/3, where pon-1/2/3 equals phase A, phase B, and phase C. While all options are viable, option A, panel pon-1/3/5, is the preferred option. This is because it is the most clear, the most concise, and is easily identifiable as a three-pole breaker. Always make sure that your panel schedule shows which circuits are protected by each breaker. If a three-pole breaker is used to protect multiple circuits, those circuits should be labeled on the breaker itself. Finally, ensure that your panel schedule is consistent throughout the entire project.